3.3a, first derivative test. Left to right is how we read in America. If it goes down, decreasing, constant. And if it goes up, it's increasing. Now we have to talk about calculus terms. So if it goes up, it's an increasing function, so f prime is positive. If it goes down, f prime is negative. All right, we're moving. So we have to figure out the intervals when it's increasing or decreasing. So I have 3x to the fourth minus 4x cubed minus 12x squared plus 5. Well, if I need to figure out when it's increasing, that means f prime is what? Greater than 0. And then if it's decreasing, f prime is less than 0. So I need to get to a derivative. So let's do it. So f prime is equal to what? 12x cubed minus 12x squared minus 24x. And then plus 5, right? No, just kidding. So what do we want to do with that now? I'm going to factor out a 12x. Let's do it. And what are we left with? X squared, and then minus x, and then minus 2. And what am I going to do with that now? Set it equal to 0. I'm going to take a derivative and set it equal to 0. We do that a lot. Well, what can we do to that quadratic, though? F it up. So what does it F up to? X minus 2 and x plus 1. All right, and I'm setting it equal 0. So I end up getting x is equal to 0, x is equal to 2, and x is equal to negative 1. Oh my goodness, you guys are all cheating. All right, so I need to figure out what intervals is negative, or what intervals is decreasing, what intervals is increasing. So we need to make our intervals now. So does this have a domain restriction? Does this have an interval in which I'm bounded by? No. So what's all the way left? Negative infinity. So now we have to go from negative infinity to what? What critical number does it hit first? Negative 1. And then it goes from negative 1 to 0. And then it goes from 0 to 2. And then we go from 2 to infinity. So I have 4 intervals in which I need to test. Right? So let's pick a number kind of on the interval negative infinity to negative 1. Like negative 2. So if I substitute in negative 2 right here, that would give me a what? A negative. All I care about is the sign of it. Okay, I don't care about the pure number. So I get a negative, and then this would be a negative, and this would be a negative. So I get a negative, 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 which is a negative, which means f prime is what? Less than 0. Now, sometimes I like to have students do this. It's going down. Okay? You following me? All right. So, this negative 1 to 0, let's pick a number that's on that interval, like negative 1/2 sounds great. So, if I pick negative 1/2, this would be what? Negative. This would be negative. This would be positive. So, negative, negative, positive is a positive. So, f prime would be greater than 0. So that means it's going up. All right. All right. 0 to 2. Let's pick a number. 1. So I get positive, negative, positive. So what do I get? Negative. So f prime is less than 0. And then if I go from 2 to infinity, I go from 3. So now I get positive and a positive and a positive. So now I have f prime is greater than 0. Yes, sir?
You're getting the positive negative by if you're just multiplying them. So like it was negative, negative, positive, 2 negatives equal positive.
Yeah.
Okay.
Yeah. All right. All right. So let's answer the question that's being asked here. When is f increasing? When is this function increasing? What intervals? Negative 1 to 0. And when else? 2 to infinity. And when is this function decreasing? Negative infinity to negative 1 and 0 to 2. All right. And so if we look at our little graphy graph, doesn't this make sense? It's going down until negative 1, and then it goes up until 0, and then it goes down until 2, and then it goes up from 2 to infinity. All right. See how that worked? All right. Fantastic. So now we're going to talk about relative maxes and relative mins. Last year in pre-calc, we talked about a relative minimum. It's that valley thing, but it goes from decreasing to increasing. Now we have to use calculus terms. So a relative minimum is found when f prime changes from negative to positive. That is something that you probably want to write down. I know it seems basic, but I'm going to ask that in different ways as time goes on in this chapter and following the rest of the year. So to have a relative minimum, f prime changes from negative to positive. If I have that change, that's where a relative minimum occurs. To have a relative maximum, f prime is going to change from positive to negative. F prime is going to change from positive to negative on a relative max. And I grew up in a suburb of Cincinnati. My parents would disown me. All right. But sometimes we had critical numbers, right? And so relatives could only occur at critical numbers. True? Remember that? Remember the start of this chapter? This derivative right here is 0. However, do I have a relative max or a min there? No, because did f prime change sign? No, f prime changed from positive to positive. It didn't change then. Are you following me? So right there is neither a max nor a min. Okay? And same thing with them both going down. So right here, f prime is negative, and right here, f prime is negative, but right there, f prime is 0. However, did it change sign? Did the slope change sign? No. All right, so I have neither. We're going to get to that maybe tomorrow. All right, pretty good? All right, fantastic. Here we go. We're going to find relative extrema of this function. So I have the function 1/2 x minus sine x. I'm going to find the relative extrema on the interval 0 to 2 pi. All right. Now, this is just relative. We don't actually have to test endpoints. If it didn't say relative, we would have to substitute in 0 and 2 pi, but we don't on this one. So, let's find our critical numbers. How do we do that? We take a derivative, and we're going to set it equal to 0. So what's my derivative? 1/2, and then minus cosine x. Very good. And so now I'm going to set that equal to 0. So I end up getting cosine is equal to what? 1/2. I get cosine x is equal to 1/2. So man, that unit circle never went away. It's crazy. When does cosine give you 1/2? At pi over 3, and when else? And at 5 pi over 3. That pre-calc teacher was right. All right, so this is at pi over 3. This is at 5 pi over 3, right? And cosine deals with the what values of it? The x values of it. All right, so let's do my intervals. It's bounded by 0 and 2 pi now, so now my interval will start at 0 to... what's my first critical number? Pi over 3. And then I go from pi over 3 to 5 pi over 3. And then my next interval will be 5 pi over 3 to 2 pi. So now I need to test these intervals. All right. So what could be on the interval 0 to pi over 3? Like pi over 6. Now, I think personally, if we're dealing with a unit circle, we don't actually have to get a pure number. We'll do pi over 6, but then I kind of want to show you another way to Tampa. Okay? So if we do pi over 6, I get 1/2 minus cosine of pi over 6. Well, what is cosine of pi over 6? Square root 3 over 2. So I get 1/2 minus square root 3 over 2. Will that be positive or negative?
Negative.
That will be negative. All right. Now, this is the way I kind of think about it. Pi over 6 is right here, true? Cosine deals with my x value of it, true? So, is this going to be more or less than the x value of pi over 3? It's going to be more. It's bigger. It's the x value. It's bigger. All right? So if I do 1/2 minus the bigger one, then what will that be? That will be negative. So sometimes I don't actually look at the pure numbers of it. This will be f prime is less than 0 there. All right? On pi over 3 to 5 pi over 3, I'd be over here somewhere on that interval right there, right? So is my cosine, my x value, going to be less or more than the 1/2? It's going to be less. So I have 1/2 minus something less than 1/2, which will be positive or negative? Positive. It'll be positive. So f prime is greater than 0. All right. And so then 5 pi over 3 to 2 pi over, or 2 pi, I'd be kind of right there. All right. Would my x be more or less than that 1/2? It would be more. It would be more. So I'd have 1/2 minus more than 1/2, which will be what? Negative. So now I have f prime is less than 0. Yes, sir?
If you're really close to 5 pi over 3, then it would be less than the x value of that.
Okay, so I have f prime being less than 0 to f prime being greater than 0. So what's happening at pi over 3? I have a relative what? Minimum. I have a relative minimum at pi over 3. Because f prime is changing from what? Negative to positive. All right. And at 5 pi over 3, what do I have? F prime changes from what? Positive to negative. So what do I have going on there? I have a relative max. Now, we do actually want to find the y value of it. So we're actually going to substitute it back into which one? The original. So let's substitute in pi over 3. So I have 1/2 times pi over 3, which is pi over 6. And then minus, now I substitute in pi over 3, so I have sine of pi over 3. What is sine of pi over 3? Square root 3 over 2. All right. Now I'm going to substitute in 5 pi over 3 into the original. So 1/2 times 5 pi over 3 is 5 pi over 6. And then minus sine of 5 pi over 3. So what's the sine of 5 pi over 3? Negative square root 3 over 2. So I'm subtracting a negative, which makes it a positive square root 3 over 2. All right. Pretty good. All right. What makes a relative min? F prime changes from negative to positive. What makes a relative max? F prime changes from positive to negative. All right. Let's do it again. So we're going to find relative extrema. So I have this function x squared minus 4 raised to the 2/3 power. So I need to find my critical numbers again. So how do I find my critical numbers? Take a derivative and that equals 0. So let's take a derivative. What comes out front? 2/3. And then I have x squared minus 4 to the power of what? Negative 1/3. Does anything pop out? 2x pops out. Thank you for remembering the chain rule. So I'm going to simplify it up a little bit. What gets to stay up top in the numerator? So I get 2 times 2x, which is 4x. And then denominator is 3. Do you want to do a cube root or do you want to just raise it to a power of 1/3? You want to cube root it? All right, let's cube root it then. So we have cube root of x squared minus 4. Now, what are we going to do with that thing? We're going to set it equal to 0. So we're going to take our derivative and we're going to set it equal 0. I feel like I do that a lot. So when do I get it equaling 0? It's not a trick question. 0. So I have a critical number at x equals 0. That will give me a horizontal tangent line. However, what is my definition of a critical number? We did this a little bit on your circuit today, and then some people didn't realize that. What is the definition of a critical number?
Does not exist.
When it doesn't exist as well. All right, when your derivative is 0 or doesn't exist. When will my derivative not exist here? At 2 and at negative 2. All right. Those would be undefined. All right. Those wouldn't exist, but they're still critical numbers. So we need to test them. What will happen on it graphically with those kind of critical numbers? They'll be vertical tangents or sharp turns. All right, more often than not, they're going to be sharp turns. All right, so let's do our intervals. So I'd have negative infinity to what? Negative 2. And then negative 2 to 0. And then 0 to 2. And then 2 to infinity. All right. All right, let's pick something. What we got? Negative 3. So in the numerator, what would that be? Negative. In the bottom, I have negative 3 squared, which would be what? 9. 9 minus 4 will be a what? A positive. So I have a negative over a positive, which is a negative. So f prime is less than 0. All right, let's look at negative 2 to 0. So let's pick negative 1. So now, what would be up top? A negative. What's on the bottom now? I get a negative 1 squared, which is just 1. But 1 minus 4 is what? A negative 3. I can cube root it still. Okay, it's an odd power, so it can still work. So it's a negative on the bottom and a negative up top, which makes a what? Positive. So f prime is greater than 0. All right, 0 to 2. Let's pick 1. So this is what? Positive. This is negative, which makes f prime less than 0. All right. And then 2 to infinity. Let's pick 3. Sounds great. So this is positive. This is positive, which makes it positive. All right. So what's going on at negative 2? I have a relative minimum. I have a relative minimum at negative 2 comma something. What's happening at 0? I have a relative max. Why do I have a relative max? Don't use the word it. F prime changes from positive to negative. All right, so I have a relative max at 0 comma something. And then what's happening at 2? I have a relative minimum. Now, why do I have a relative minimum? Don't say it. F prime changes from negative to positive. All right. Guess what I have to do on a test if you justify your answer by using it? I have to mark it wrong. Because guess what AP is going to do? They're going to mark it wrong. Okay, they're naked answers. Don't be like that. All right, so now we're going to substitute back in to find where they're located. So if I substitute back in negative 2 right here, what do I get? Negative 2 squared minus 4 is 0. So I get 0. And then if I substitute in 2, what do I get again? I get 0. So my relative minimums are happening there. A relative max, now I substitute in 0. So I substitute in 0 right there. So I'd end up with negative 4. But now I raise it to the power of 2/3. So let's square it. So what's negative 4 quantity squared? 16. Now, cube roots. Does it play nice? No. So my answer is cube root 16. All right. And there's what your graph looks like. All right. Do you see how it goes down? Then it goes back up. And then it goes down. Then it goes back up. Now, do you see how these are sharp turns? Yes. All right. Those are sharp turns because that's where my derivative doesn't exist. All right. This one is nice and horizontal because that's when f prime is equal to 0. See how that worked? All right. Cool. There you go.